Welcome everyone to this edition of Flower Monthly. We're rocketing through the year. This is August already. I'm so excited about how much has happened already so far in the world of federated learning, and also frankly for Flower too. So it's so great to be with you again this time. Before we kick off into the agenda for today, just a quick little reminder about what we're trying to achieve with Flower Monthly. This is a casual information sharing session that we run monthly on the first Wednesday of each month. We try to repeat the start time consistently so you can kind of get used to the rhythm. And then we have a variety of content. Sometimes we share information about updates about the framework. Sometimes we have how-tos. Often we invite people to tell us how they've been doing interesting things in the world of federated learning and in the world of Flower. But as always, suggestions are welcome. This is a completely community-driven event and framework. And so, yeah, please tell us if you've got suggestions on how we can improve things moving forward. Today, I am really excited about what we've managed to put together for you. We're going to have around about 5 to 10 minutes of a few Flower updates, just letting you know about a few things that have happened in the community in the last 30 days. And then we're going to launch into a couple of exciting invited pieces of content. So the first of these is going to be an experiment for us. First time we've tried this, we're going to have a small interview. We've got 2 people here who are blazing a trail in their standards. We have Patrick Foley here and Daniel Beutel, that you recognize both of these folks, I think. They're working on an OpenFL consortium along with a lot of other people, where one of the interesting dimensions to this is how it is trying to advance federated learning standards. And so we're going to have a nice casual chat about this effort. And it was largely prompted by a guest blog that Patrick posted on our site just this month. Then we will move on to our second invited talk or piece of content, and that will be by Fiona Victoria. She's also joining us today. She is a student at the University of Washington who's come up with a pretty interesting piece of technology, which is a federated learning version of these diffusion models that have been really setting the world on fire. And so when we saw this piece of content come out, and we were naturally we're excited that she decided to build this on Flower. We thought, oh, let's have Fiona on and to see, to learn more about the technical details of what she's accomplished. So yeah, thank you, Fiona, for also joining us today. So let's move on to a few quick Flower updates. This is going to be fairly rapid fire. We've got some folks from the Flower core developer community here to talk about some of these things. The first of these is something that many of you would be aware of, and that is the summer of reproducibility. We are now into month 2. It started around early July, and so I believe it's going excellently. And I've invited here Javier, who's joining us, who's running this whole initiative, to tell us more about it. Maybe Javier, you want to remind us about what's the big aim here, and then give the folks a bit of an update about how things have gone so far.
Yes, so well, Summer of Reproducibility is like a 3-month sprint, where the goal is we have compiled a catalog of 50 baselines. Most of these are papers from high-profile venues, like from roughly the last 3 years, touching upon different sub-communities within federated learning. So the idea is can we build this catalog of baselines so people developing the next generation of federated learning methods can use this as their foundations of their research papers, or even maybe different prototypes that people might use in industry. So far out of the 50 baselines, close to 40 have already been chosen by either authors of the papers that they were willing to convert it into a Flower implementation, or by other people out there that are interested in federated learning and want to give it a go. So I think there is a lot of activity, and there are still a few highly popular baselines that you might want to choose. So if you are interested into this, you should go to flower.dev/summer, and you will see all the details there. Of course, you can reach out to us on Slack if you have any questions or how this works and so on. And
Excellent.
I think we have a blog post about it as well. So, yeah.
Great. Thanks, Javier. I think it's going amazingly well, and I hope that by the end of this 3 months, we really have shifted the needle in what folks can do in terms of reproducibility in the domain of federated learning. So thank you. Another thing that we've done in the last 30 days is to Charles. This is a bit about Charles, and Charles is not a panelist. He just signaled to me. Let me just make him a panelist. Great. And so this next piece is about documentation. We really wanted to start to revamp the way that we present documentation and make it easily accessible to our users. And so Charles has been driving this forward among other people on our team. And so Charles, do you want to maybe tell the folks about what's changed with documentation and how it might change the way they find things?
Yeah, sure. So what we've done, first of all, is to separate the different projects we have in different documentation pages. So this is all in an effort, as Nick said, to make it simpler for users to find pieces of information. And we've also separated a few important examples. So for instance, the Android SDK right now, it's just redirecting to the Android example using Flower. It is the same for the iOS SDK, but soon we'll be able to deploy the full documentation for the Swift code. And then we also have a new project, which is some example projects, and which are now listed all on the same page. And so this change is to make sure that the docs are as accessible as possible. And it's all in an effort of allowing beginners to get familiar with Flower more quickly. And this also relates to the next slide, I think.
I think the next slide actually is something that was driven by Julian. This next slide here. Yeah, so let's visit Julian here. He's sitting here. I see him on my left. So Julian, I think you've really tuned up the Flower YouTube channel, haven't you? Tell us all about it.
Yeah. Hey everyone. Just quickly talking about the channel. We just changed a little bit the appearance as well, just bringing it more up to date. It was not so fitting, was a bit empty before. But in general about the channel, I mean, we started this in 2021 when we uploaded it as just recordings from a first summit. And it kind of developed into a project we're growing to be more passionate about. So we're uploading more videos about recordings of the monthlies we did and the summit we did, and also tutorials more and more. Some of the first tutorials we uploaded were from the summit actually, which were never meant to be a standalone video or just a live session, but those were very well received. It's just showed us that the videos are just a great way for us to communicate with our community, and that reading docs is one thing, but also watching videos is quite popular. And I just wanted to say that, stay tuned. We're releasing more content, and we're just recording, and I think it's a very good medium to stay connected to our community, and we see that it's very well received. And also a shout out that if you have any suggestions, any requests, which topic we should cover, please reach out. Feel free to talk to us. We're very happy to collaborate, or I'm very happy about any ideas about videos. We're just trying to build a cool basis of videos, and on the one hand, educational content, but on the other hand, also just topics general about federated learning, any talks you want to present maybe. And well, we are a YouTube channel, so I got to say it, like and subscribe, follow to not miss any new updates. And I mean, you can see already on the image, the latest videos a really cool tutorial series by Javier, but I think Charles is going to talk more about it now.
Yes, was one of the main things we found is Julian was mentioning. We noticed that some of our most highly watched videos were those with tutorial content, and we found even tutorials that had maybe perhaps even gone a little bit out of date as the code has progressed so quickly. We're still being watched intently, and so we've launched a number of new Flower tutorials, and that's what I want to talk about next. As you see here, we've got two tutorial streams, one to do with quick start, how do you onboard into TensorFlow, and one to do with federated simulation, because it's a great way to get started in this type of technology. And so the two folks who've been driving these tutorial series that we've been posting to our YouTube sites are with me here, Charles and Javier. So maybe let's start with Charles. Do you want to tell us a little bit more about what you want to do with the quick start tutorial and how far it's gone? What's this first video about? And so forth?
Yeah, sure. So the first video is somehow for people that are already a bit familiar with federated learning. So the idea was just to put that out there and to see the feedback of the community and what they wanted to see. So right now, this is just a basic example using TensorFlow of how to go from centralized TensorFlow code to federated learning. And the plan for the next one would be PyTorch. It's probably going to be released next week. But then it's really up to the community to help us understand what's really needed for the next few tutorials. From what I had in mind was to make a series for beginners, maybe not yet for absolute beginners that are not aware of what federated learning is, but at least beginners with Flower, and to break down some of the basic elements and components of the Flower core framework. And I think this is the approach that Javier took with the Flower simulations. So, yeah.
Great. And that's a great segue to Javier. So tell us about your tutorial series.
So my tutorial is I think it's fine for beginners. There is not like a big slide where I explain all the concept of federated learning. So here in this tutorial series, we jump straight into the code directly, and we develop line by line a complete federated learning pipeline. So we see how you start with a data set that maybe is not partitioned, so you need to partition it, how we can do it. I do it in one way, but then I add some comments on why you might want to do it in different ways. Then we look into how to create a Flower client, how to choose a strategy, and what is so important strategy in Flower. And then we complete the entire simulation. We look into what are the key ideas to take into account if you want to optimize your simulation. So you maximize resource utilization with all the components you have available, whether it's just CPU system or maybe even multi-node with GPUs. And towards the end, we look into how to make this working with federated learning experiments where we often use multiple data sets, multiple models, how to make it much more versatile by using a configuration system that is based on Hydra, which is an open source framework from Meta. So I think it's fairly complete. Even if you are already familiar about Flower, I think there is something you will learn in this tutorial series. So I encourage you to check it at least.
Perfect. Well, that wraps up our sort of whirlwind tour of a few sort of landmark things that have happened in the last 30 days with Flower. And we're going to move on to our first main event of Flower Monthly this month, which is our experiment. We're going to try an interview series. And so for the first interview series, we're going to discuss federated learning standards. And in thinking about this topic, I could think about no better people to ask and discuss this topic than Patrick Foley, who is the OpenFL lead architect and an engineering manager at Intel, and Daniel Beutel, who I'm sure many of you know. He is the co-creator of Flower, but also on the OpenFL consortium. He is on the technical steering committee. And so just to sort of tee this up a little bit, I'd highly recommend that you check out Patrick's guest blog on federated learning standards. The URL is at the bottom there, or you can easily just go to the blogs and you'll see I think it's the most recent blog that was posted. And he described the need for standards and the work that's underway within the OpenFL consortium to make progress on this topic. And most importantly, a call to action to anyone who's interested in this today. And so during this interview, if you want to ask a question, raise your hand. And what I'll try to do as an experiment is allow you to talk, and you can tell us what your question is. It's the first time we've done this, and so we'll see how it goes. I've got a couple of questions for these guys here, but I think it'd probably be natural to also stop sharing so you can see them more clearly. And then I'll just kick things off with a sort of obvious sort of question. So Patrick, maybe do you want to tell us what OpenFL is all about and trying to accomplish, to give us sort of a landscape view of this?
Yeah, absolutely. Thank you, Nick, and thanks for having me for this interview panel for the Flower Monthly today. It's great to see the community that your team is putting together and in this format. So OpenFL stands for Open Federated Learning. It's another federated learning framework that started in the 2017 timeframe through Intel's partnership with the University of Pennsylvania, developing a set of federated experiments for brain tumor segmentation. That ended up being used in one of the largest healthcare federations worldwide. So OpenFL has gone from being a research piece of code to something that is intended, and it's been taken to production, and is now being transferred over from Intel Labs to a different development team within Intel. And in the last, I think 6 months, we actually moved the project from Intel to the Linux Foundation, where Daniel joins us on the technical steering committee for OpenFL, in addition to VMware, Leidos, and the University of Pennsylvania. So this is now a community-driven project, and the work on federated standards really speaks to the community-driven need that there is in federated learning to have a basis for interoperability between really nascent frameworks that have come up since the Google paper in 2016.
I see. Excellent. Maybe Daniel, so you've been joining a few of these steering committee meetings so far. What have the topics been discussed within the steering committee?
I think the interesting thing is that there's been such a wide range of possible topics that are just begging to have discussions about for standardization. And it's quite interesting if we look at the evolution of federated learning frameworks. I think there are quite a few parallels to how regular deep learning frameworks like TensorFlow and PyTorch have evolved, where before these frameworks existed, there was sort of the Wild West. Everyone just hacked something together. Then eventually different frameworks emerged. We had this just a huge variety of different frameworks. And then eventually we saw different patterns emerge in frameworks. So frameworks started to converge towards a common set of components, something like in a regular deep learning framework, it would be something like an optimizer, for example, or then just a notion of a model and things like that, loss functions, for example. And those have been built into these frameworks. And then eventually over time, I think people realized that some level of compatibility offers a lot of upside, actually. And then first steps towards compatibility have been taken, where in regular deep learning, for example, something like Onyx is there to create compatibility between these frameworks. Now, for federated learning, we're sort of in this in this stage where it's not even perfectly clear what kind of components exist in these frameworks. We're starting to see some of these components emerge. We're starting to see that these frameworks, for example, they have something like aggregation needs to happen somewhere, client selection and configuration needs to happen somewhere, some portion of the workload needs to happen on the client, model parameters need to be serialized and sent over the network and then received again. Things like that are starting to emerge, but I think we're still at this interesting point where different frameworks approach it in very, very different ways. And as we've seen in the regular deep learning space, where we have some level of compatibility between these frameworks, we suddenly see that, for example, infrastructure like cloud infrastructure starts to support these standards, and suddenly things become a lot easier to use, a lot safer to use, and it's a lot more economic to build these kinds of workloads. And we are hoping with the standardization effort to go in a similar direction.
Excellent, excellent. So I guess, Patrick, a natural question that comes to my mind would be, once we, I mean, this is kind of a fast forwarding question, and then we'll backtrack. But a fast forwarding question would be, where can this take us? So once we have these standards in place in a couple of years down the track, what do you think might be enabled in that case?
Yeah, so from my perspective, it's really exciting in terms of where the future of standards could take all of these federated learning projects that today are somewhat siloed in their approach, and what a future could look like is a recognition that there are unique benefits for the way that different teams have developed these projects, and by having standards that allow them to interoperate. That really allows people who want to deploy these federations for themselves and start these projects to have the best of both worlds in many ways. So Flower's done a fantastic job of building, multiple language interoperability. I think starting largely as a Python framework like OpenFL, but really building a lot of support for mobile devices. I saw the C++ is one of the SDKs that you're working on. It's really exciting to see that kind of interoperability from the language perspective. And then on the OpenFL side, we've been putting a lot of focus into privacy and security through the use of trusted execution environments. And so we would love to have a future where it's possible to use some of the Flower interfaces and build, on the community passion that's been that's very evident for the interfaces that you've built, and have that run within a trusted execution environment, and even have these hybrid environments where there's maybe an OpenFL aggregator and Flower collaborators that run on iOS or Android devices. So those are some of the ideas that I think that we've been brainstorming and talking about when we think through the next couple of years about where this could go. But that's really just the start too. I think there's lower level components too that allow for new higher level frameworks and interfaces to be built on top of. And so there's a lot of potential going down that direction too, in terms of not just the benefits that each of us bring in terms of our capabilities, but new ideas and higher level abstractions that we haven't thought of yet.
Right. I think this is probably a good point to pause and see if there's any questions from folks in the audience at all. So if you're out there, just raise your hand. If you're one of the panelists, you can visually raise your hand. We've got a question already. That's great. This is from Pedro. I mean, if I know the person, I'll say where they're from. If I don't know where you're from, I'm sorry about that. But I know Pedro is from the University of Cambridge. I'm going to press the button so we can talk. So Pedro, I think you're able to speak right now.
Hi. I hope you can hear me. Thanks for the intro. I was just wondering, will the standard also look into security protocols for FL?
That's a great question, and maybe I'll start with that, and Daniel, you can jump in too. But my thinking is that it will. So we have we're going to start, I think, by looking at some of the serialization standards and network communication. But the way that those standards are designed is intended to be done in a secure way that is amenable to review by different cloud providers. I think Daniel is you were saying, and then as far as the security standards go, on the OpenFL team, we're working on a set of capabilities that enable the trust of, or the use of trusted execution environments. And we intend on open sourcing that in the near future. And so longer term, there's that we have the intent of making those types of interfaces that we're starting with OpenFL in terms of the security properties that they enhance, and bringing those to other frameworks. That's the direction that we would love to go. And so the security standards direction is certainly something that we would love to be able to collaborate on.
Absolutely. Maybe just to add a few comments, I fully agree, first of all, with what Patrick was saying. And I think it's an excellent question. I think security is actually one of the areas that I'm most excited about when it comes to standardization, because we're currently building, for example, a new way to do secure aggregation into Flower. And this is not an easy thing to build, and this requires quite a lot of dedication, requires quite a lot of thinking and code review and so on to get right. And it would just not make sense for all of the frameworks that are out there to reinvent these pieces. And then OpenFL, for example, has done pioneering work when it comes to execution and trusted execution environments. Intel probably has the best people in the world when it comes to Intel SGX and things like that. So it would only make sense to have these components usable in a standardized way, and then for other frameworks like Flower to just plug in these components and use them and rely on them as a bulletproof implementation.
Great, thank you, Petra, for the question. I'm happy to take another question, and then we can go on to a few other questions I had, if there's any. Okay, Francesco from INRIA, let me allow you to talk. Feel free to ask your question.
Thank you. Hi. As the developer of yet another framework, I was wondering if you plan to open the committee to participation from outsiders, and in general, what is the plan for publishing standards, and how can we, make sure that we comply to them? Thank you.
Daniel, do you want to start with that one?
Absolutely. I think the intent of putting out the blog post and having this session today, and also probably Patrick's talk at the last Flower Summit, is exactly to invite other framework authors to participate in this effort. The OpenFL codebase recently moved under the Linux Foundation, and there we have this shared space where these standards can be developed together. It's we are in the process of setting up the repo where we will, similar to how Python does it with the pip process, if you're familiar with that, where we'll start to write down our thinking about this, and then start to evolve these standards. And it's the most immediate thing that anyone can do is check out the PRs, make comments on the PRs, contribute to the PRs. And then eventually also participate in the discussions around it.
Yeah, Francesco, it's great to see another framework author team that's joining this call today, and I fully agree with what Daniel said. So we want this to be a very collaborative effort and seek community feedback in terms of how these standards are developed. I think the intent for the first couple is to really have these proposals that are based on the PEP process for Python, and just get a couple of examples in this repo first in terms of what the structure of the proposals will look like. But certainly your feedback and others in the FL community is going to be critical to making sure that these are successful and taken up by not just Flower and OpenFL, but others.
Great, thank you. So then, I guess one question that I was going to ask while we wait for other people who might have things to ask is, I wonder if we could dive down into one of these components, because I noticed when Daniel was speaking in particular, he was sort of outlining a lot of different things that we could work on. And it can clearly, there's a lot of places where these things can connect, these frameworks and so on. So I was kind of curious about if we could just sort of dive into just one of these things that you both might feel passionate about. So feel free to discuss and find which one you might have an interest in. And then, yeah, just discuss with everybody what would be this particular component, what level of interoperability exists right now, and then what would a proper standard look like, and some of the issues that might sort of emerge from that. And that might also prompt some discussion from the audience too. They might disagree with some of the things said, which would be fantastic, actually.
Absolutely. Should we start with serialization, Patrick, or?
I think that's a great place to start. Yeah.
Absolutely. Do you want to go ahead, or should
Sure, yeah. So I think we've been talking about, so Daniel, myself, others on the OpenFL side and on the Flower side have been talking about serialization standards for a bit of time now. And first, just to define what that means, there's both OpenFL as well as Flower use gRPC and the protobuf definition as the mechanism for communication between client and server. There's other frameworks that define that network communication in different ways, but that protobuf definition looks fairly similar between OpenFL and Flower today in terms of the ways that's defined. There's some differences in terms of how models model weights get sent across the network and what gets embedded within these messages. Flower passes models entirely in their entirety, whereas OpenFL passes them on a layer-wise basis. Flower has to deal with big endian as well as little endian use cases because of the different clients they support. And OpenFL is starting to look at other types of information beyond just NumPy weights that could be sent across the network as well. And so this is giving us an opportunity to think about what are the common pieces that are going to be needed between Flower and OpenFL. And as we broaden the conversation to others who want to participate in this, really what that common denominator is in terms of supporting the maximum number of use cases that we can, and have well-defined policies in place so that what is being sent across the network is reviewable by someone who let's say a healthcare institution and their IT security team that wants to see what's actually going to be loading their data locally to make sure that nothing is being exfiltrated outside of their walled garden that shouldn't. And so being able to place some limitations in terms of information that gets sent across the network, and having well-defined ways of the types of transformations that can occur either on a client or on a server, and making those pieces interoperable too between frameworks would be I think there's a long thread of potential directions that we could tackle just from that alone.
I think maybe just to add a few words to that, what I found fascinating in those discussions is how many pieces of the stack are actually impacted by those decisions that you make early on, especially when it comes to serialization. With serialization, there's these different approaches to build a framework. For example, you could, at the point where the message arrives on the server side, you could immediately deserialize it and then just pass around between different components the deserialized version of a message. You could also build all of these components to expect the serialized version, and then the component would deserialize it itself if that's necessary, because many components don't need a deserialized message. There are pros and cons to both, and other things that will probably come later in those standardization discussions. Things like aggregation or compression and things like that, all of those are impacted by those early decisions when it comes to serialization. And one of the things I found very interesting, and that also gets me excited about this standardization effort, is the fact that I think often when people talk about standardization, it feels a little bit like, okay, standardization is the thing that everybody can agree on. We write down the sort of this small thing that everyone agrees on, and then that's something that everyone can implement. What was interesting for me in those discussions was suddenly we talk very in super detailed terms about these components, and it helps me to understand better what, for example, OpenFL has been doing. OpenFL understands better what Flower has been doing, and we see really in super zoomed in what are the things that are enabled by the way of modeling it like that? What are the limitations of a certain way to approach it? And through those discussions, we learn from each other, and new ideas come up. And I think eventually this will not just result in standardization and better compatibility, but it will result in better frameworks overall, because everyone tries to discover this space and tries to build a good solution. But through the interaction between different frameworks, we learn from each other, and we'll eventually be able to build better frameworks through that.
Excellent. I guess when you guys have both talked about this topic, where do you think have there been any examples of disagreement, or just violent agreement? Or I'm just kind of curious about how close to the coming up with a design of this the members of OpenFL are, in fact.
Yeah. Sorry, Daniel. Do you want to start first?
Yeah, absolutely. So one of the things that I think there was a lot of violent agreement about many things. For example, that we should be able to serialize not just NumPy ND arrays, but also other things, and really make this transparent on a communication layer. What I found interesting, and what I wanted to also, maybe the reason I wanted to start this time, was I wanted to thank Patrick for inviting me to the OpenFL TSC, because I think in this round the discussions have been very very open. Everyone was really saying, okay, this is how we did it, but here's 5 things that is wrong with that we wish we did in a different way. And through that, I think this was a super healthy debate, and super interesting for me also to learn more about other approaches.
Yeah, thanks, Daniel. And I would agree. I think that there's mostly just been agreement so far on the different topics that we've looked at. And when it comes down to it, we started. I mean, everyone who's worked on a federated learning framework makes decisions early on, and those impact a lot of the future design of what the framework looks like. And so this really gives us an opportunity to at least on the OpenFL side, to revisit a lot of those decisions and figure out what the best way is, and where others have made choices that's led to better outcomes over the long term. So it's really exciting in terms of where some of the common components that we can start with, because serialization is certainly high impact. I think compression is certainly another of those, as well as aggregation algorithms. It's refreshing to hear about the focus on reproducibility within the Flower team, because I think that beyond just the algorithmic reproducibility, once we have standardization really making some traction, then there's going to be more reproducibility at the framework level and across different frameworks as well, which is going to really, I think, be a boon to researchers who want to verify their implementations, and also for framework developers who want to make sure that they're not calculating something wrong or have off by one error. So yeah, it's been, I think, a great collaboration so far.
Great. Well, then I guess I would invite anyone in attendance if they want to ask additional questions. We've got a few more that we can run through, but don't be shy. This is mainly for yourself if you have anything. But I was, while we wait to see if anything else is going to pop up. Another question I had was a sort of obvious one, just a small one, was do you think that this will be the first thing that is agreed upon and maybe starts to be implemented in multiple frameworks, or is there something else that you think might be a standard, sort of an agreed upon standard ahead of it, or any thoughts on that?
Serialization is up there for me, just because I think that there's a lot of overlap in terms of and that leads to, I think, will lead to traction in terms of being able to get these standards defined relatively quickly, which I think is going to provide more motivation to build other standards on top of that. I think there's certainly other candidates for where we might want to build some standards early on too. How tensors are stored and what the database for this looks like. We've talked in the past about authorization policies for which collaborators or aggregators are able to access certain layers within a model, and really defining what that would look like would also lead to this framework interoperability that I think is one of our goals over the long term. So I think there's a lot of potential directions we could go, and certainly on the OpenFL and Flower teams, we're going to have, I think, things that rank near the top of our list. But because this project is open source and we're already hearing from other framework developers who want to be a part of this, we're going to get some other, I think, ideas along the way too, and those could move their way to the top of this list.
Daniel, anything to add? Or?
Absolutely, I fully agree. I think serialization has high impact. I'm curious to see what solution we'll arrive at, and maybe the first solution will also not be perfect. That's rarely the case. And I think the beauty of a standard is also that we can evolve the standard over time, that we can propose additional versions of the standard, and then say, here's version 1 of this standard, everyone implements it, we get a confidence in what works, we might see that some things are not fully spec'd out yet, and then we'll evolve the standard along these lines.
Great. Oh, wait, we just got another question. So it comes from Juan, and he asks, how are you going to focus on federated data sets and federated synthetic data generation? So I'll put it out there to you both.
That's a great question, and that has not been at the top of my list, but I think there's good reason for wanting to have those that capability in place, because it's something that this goes back to every choice that framework developers make, and we have our own ways of developing these federated data sets. But I think there's a lot of room for exploration on the research side, and having well-defined standards for that would certainly lead to experiments that can be reproduced across frameworks. So I love that idea and would love to see, I mean, once we start making some traction on these proposals, see one from around that federated data sets and generation of synthetic data, because that seems pretty interesting.
Yeah, I fully agree. I think especially the aspect of federated data sets and how clients load data, and how maybe clients coming from different frameworks could access local data in the same way. I think this is a key topic in federated learning. And then federated, generating data sets, this could be something where once we define the standard on how these data sets are being loaded, what sort of the interface between the federated learning framework and the data source is, then there could be different tools to generate these data sets artificially or in whatever way locally. Yeah.
Great. Well, we're starting to run out of time, but this has been a great kickoff for the interview series format of content we've been looking to introduce in Flower Monthly. And so I really want to thank you both for coming today. It's been a great first edition, and I think it really has provoked a lot of interest in the community, and hopefully a lot of follow-on activity. So again, thank you, Patrick and Daniel, for doing this today. Thank you.
Yeah, thank you very much for having me. It's been wonderful collaborating with the Flower team.
Perfect, and likewise, we've always loved working with you too.
Absolutely.
I would just say that if anyone wants to look at the repository that was mentioned during this conversation, that's been set up there for where these standards can eventually be put, and they can, a neutral source of where people can put code and so on. There's a link, for example, in the blog that Patrick posted, and I'm sure you'll better find that link in many other places too, but that's one natural place if you're looking for it. Great. So with that, let's move on to our second main event of today, which is this talk by Fiona Victoria. She is a student at the University of Washington, and To be honest, one day I'm always looking at papers that happen to be citing Flower, because I'm kind of curious what people are doing with it. And then one day I was just browsing through the list on Google Scholar, and I found a really provocative title, at least to me. Had a great name, Phoenix, and it was on a really topical, highly topical domain of diffusion models. So this, of course, the models that are driving things like stability AI and a lot of this Gen AI hype, which is really shifting the needle on applications in the space. And we think, at least, when you combine that with federated, some really magical things are possible. And so then I reached out to Fiona. She graciously said she'd be happy to give a talk at Flower Monthly. And so Fiona, thanks for joining us today. I'll stop sharing so you can show us your slides. And I'm really fascinated to hear what you've been working on.
Thanks, Nick. Super excited to be here, and thanks for inviting me to this talk. I think it's truly an exciting time in the age of Gen AI, and I think this topic is aligned to what's going on out there in the world. So I can share my screen. Are you guys able to see my screen?
Yeah, it looks great to me.
Okay. So this was a work that was done during my time as a graduate student at the University of Washington, Bothell, alongside my research advisor, Dr. Afra Mashadi, who's also an active contributor and a collaborator, who's also been in a couple of meetings here with Flower. And the title of my work during this time was Phoenix, which is a federated generative diffusion model. So before I go into the whole, the work and what I did, I wanted to give a bit of a background to it. So Gen AI, in the context of images, is usually reliant on 3 different models, which are your variational autoencoders, your GAN networks, and diffusion models. You may have heard of these GAN networks being used more often than not, and that is very typically a discriminator and a generator network that kind of pit against each other, and then they try to fool each other till they can generate really good images. However, I wanted to go a little different direction, where diffusion models is something that hasn't been yet thought of in the domain of FL. And so decided to go a little bit deeper in working on that. So diffusion models are probabilistic in nature, and they were actually inspired by physics. And they work in a way that they learn how to create something out of just noise. So that's pretty fascinating, and I can show you in a second as to how they really do that. And if you go a little bit into diffusion models, there are 2 types of it. One is your conditional, and another is conditional models. An unconditional neural network model is essentially one in which you don't really provide any kind of a prompt or a text, and it just generates something out of a random seed value. So you just give it noise, and it's trying to essentially create something out of nothing. But in terms of a conditional diffusion model, you would actually tell it exactly what you wanted to create. So if you gave a prompt of, say, a girl holding a duck, it would actually follow those text prompts and generate an image that is closely resembling the text prompt. So the work that I'm talking about is mostly focusing on diffusion models in an unconditional sense, where I'm just going to provide seed value and ask the model to generate different types of images based on what it was trained on. So diffusion models, like I said, are generative models, and they are probabilistic. They're a very simple 2-step process where you have your forward diffusion model, and you add Gaussian noise in iterative test steps, and you try to noise this image. And during the reverse diffusion process, you employ a neural network model to learn how much of noise is added to these images, and you try to remove them iteratively till you can actually get back the original image. And that's a pretty new process, because an image which was just noise, when you try to denoise it, you don't really get the same image back, but you end up getting variations of images because of the noise that was added to it. And this is the super special process of diffusion models, which is why we're able to create so many variations of image, although it was just trained on a very small subset of samples. So why FL for diffusion models? I think the main reason I picked FL was because it can create high quality samples, and there's ample mode coverage, and they also don't suffer from the instability or conversion issues like GANs, which is a common problem as noted by Google itself. And why diffusion model is because there's a lot of there's on-device data, and by using FL, you can also promote that there is a lot of privacy and security of both the users and the different data that they're being shared. And this also enables collaboration from multiple institutions. So if you use FL for diffusion models, it is actively can be used by healthcare industry, by the autonomous vehicle industry, and also in factories and environment. So in terms of health, you could use it for applications where you want to generate large amount of anomaly synthetic data where you don't have a lot of real samples. And in case of AV, you could use it for real-time monitoring. And in terms of factory, you could use it to generate a lot of defect items, or you can try to simulate how something would look like in a production line, thereby optimizing it. And in terms of environment, you could use it to generate real-time scenarios of how the world would look like if there was a tsunami or a tornado. So that would be helpful for forecasting climate change. So Phoenix is the model that I trained on a FL setting. And the main use of this model is that it addresses the issue of statistical heterogeneity or class imbalance. So what is statistical heterogeneity is that typically this is a common problem in FL wherein you don't really try, let's say you have a scenario where there are 10 different clients participating in a training. And there are times in which certain clients don't really have all of the classes. And when you try to aggregate them together and you ask the server to generate something, it might have never learned a lot of samples. So it's not going to be really representative during the test time. So this class imbalance is not really an ideal scenario in diffusion models, because if it hasn't seen a lot of classes, it's not really going to generate those classes during test time. So I'm trying to learn how I can address these issues, and then came up with two strategies called the data sharing strategy and the personalization in order to combat this main issue. So the first is the data sharing strategy. So consider a scenario where you have a global model and you have multiple clients which are connected to it. A data sharing strategy works in a three-step process, wherein in the first round, you have a global model, which is trained on a small portion of data that I call my globally shared data, or G. So this is usually just a small segment of data. So consider I'm using a CIFAR10 data set, which has 40,000 training data. I'm going to isolate a small portion of that and call that my G. And I'm going to train a global model first on its small subset G. Once I have a good model on the small data, I'm going to share the weights of this model to all my different clients, and also share a small segment of this G to all the different clients. So what happens now is that all these clients that might not have all the different classes it needed to have might have learned some of those qualities from the global model. So when you do this and you do that in iterative steps, you ensure that there is equal representation of all classes. So if you kind of repeat this process over, say, 10 server rounds, 100 server rounds, in the end, the global model is going to be really powerful enough, because it has also learned all the different local data, but also learned how to represent this small portion of G. And this is one way of ensuring that you can, deal with the class imbalance issue. The second is a little interesting, and it was just a idea that we came up with, which is personalization and threshold filtering. So personalization and threshold filtering is, again, a three-step process. And in this strategy, the first step we do is you personalize these layers. So FL, typically, we consider that all the clients have the same exact model architecture, and they have the same hyperparameters. But here, decided to personalize some of those layers. So what happens in this case is the last couple of layers, or the last basic blocks of this neural network models, are quite different for different models. So they are pretty adaptive to the local data in these different clients. So once I personalize these layers, I then ask these local devices to generate samples for me, and then I continuously monitor their performance. So what I mean by monitoring performance is by actively asking it to generate me, say, 1,000 random images from the diffusion model, and I'm going to measure the FID score, the IS score, the precision and recall. So this is done actively in order to find out what's the diversity of the images being generated and what is the fidelity of the generated images. Once I keep recording these metrics, I'm going to keep, disconnecting or unregistering the underperforming clients. However, it's not really ideal if you just, disconnect a client just because it did not perform well in one server round. Maybe there could have been an issue where it did not have good network, or at that particular server round, it did not have really good samples. So rather than just disconnecting them after, the first time itself, I'm employing a two-strike approach where I give a chance and keep monitoring those warned clients, and I just keep looking at them. And the minute I see that they're actively doing it again and again, and they're just not performing really well, I end up disconnecting these underperforming clients. And what happens because of this is that I can, maintain the class balance and also make the convergence process much faster. So these poor clients are not really dragging the performance of the overall model down. And I see by doing this process, you can still generate really good samples and still maintain more diversity. And here are some interesting results from the first strategy that I employed, which is data sharing. So I use a DDPM model, which is actually a diffusion model, which is based on the differential, probabilistic in nature. And I use it with a UNet backbone, which is the standard neural network architecture used to do the reverse diffusion process. And the two variables, like I mentioned, which are my alpha and beta. The alpha would be my local data, and my beta would be the small segment of global data that I had initially allocated. So by doing these different experiments, it was noted that as I kept increasing the beta, the performance of the precision and recall kept increasing. However, it was noted that it did not really matter how much of local data I shared back to the different clients. Even if I just sent back 20% of it, or even 100%, it wasn't really, making a lot of difference. And that you can see in the third graph, because, the graph stays pretty flat there. The fourth is a little different, and this was something that we just came up with as to how do we really measure the mode? How do we measure the coverage of the classes? We keep saying that I'm trying to address the issue of class imbalance, but there should be a way that I can actually look at it visually to say, okay, these classes are not being actively covered and these classes are always being repetitively generated. So for that, we came up with a way wherein I use a pre-trained neural network model called the, we just use one of the state-of-the-art pre-trained models, especially for CIFAR10. And then I feed all my generated images to this model, ask it to tell me what class they might belong to. And then I kind of plot all of them to see the frequency of occurrence. So the red line is kind of the base or the ideal scenario we would want. That is, if you had a CIFAR10 test set of 10K samples, there's usually 1,000 images for every class. That's usually the ideal scenario. However, we see that since we're using an unconditional diffusion model, where we try to generate something out of seed noise, it's not going to be really possible to replicate the same thing, but we're trying to ideally bring it to a flat line. The first, which is the blue line, shows where we have employed no sort of class heterogeneity, nothing to combat it, and that's just a default training. And it shows how certain classes were just queuing the results. So for instance, class 0 had almost 6,000 images, where some of the classes had no images at all. But when we tried to employ this data sharing strategy and we improved the beta, we could see that it was trying to at least generate more samples across the board. So that showed that, yes, the model has learned how to equally generate images of all different classes, especially from CIFAR10 dataset. And the next is the personalization threshold filtering. So like I said, this is a two-strike approach. And I use the last basic block of the unit model as my personalization. The results are pretty good, and they are much better than that of a default training. However, the precision and recall did not beat that of the data sharing strategy. The main reason was because we are using something called the filtering, and we end up disconnecting or unregistering some of the clients that don't perform well. There are chances that these clients may have had the only classes that no other client ever had. So by taking that certain client off, you might not let it participate in certain rounds, and thereby the final global model might have not learned certain classes ever during the whole training. So that's one of the reasons why the performance is not as great as that of the previous method. But it was certainly interesting trying to experiment with this method as well. And the graph is quite similar to the last one, where you could see it was trying to flatten the curve, but not as much as that of the previous method. And I guess putting it all together, we could say that the Phoenix does outperform the default training. But if you compare the two different methods that were put in place, the data sharing strategy significantly performed. By just sharing 4 to 5% of the global data, we could show that there was ample performance boost across the board for precision, recall, and inception score. And the best thing about using DDPM was that it was a very stable training. Unlike GAN models, we wouldn't have to actively look at the training and learn when to stop it, because it's not going to start behaving unstable or fluctuate in training. So that was a good thing as well. However, the things to note here is that it's highly, computationally expensive. DDPM models have almost 35 million parameters, which is 6 times that of a GAN model. So since there are 6 times that many million parameters, we're going to have the same number of hours, extra hours to train them. So that took along, 11 to 12 hours per server round, which is not ideal in at least an FL sense. And these are just some of the generated samples that you would see using a default diffusion model where you don't really take care of the class imbalance. And you can see in data sharing strategy, you have much better images with high fidelity. And the personalization is quite comical in nature in terms of the images generated. And it's not, really beating that of the data sharing strategy. So here are some of the open source contributions I think might be really good and beneficial to the community as well. So one thing that I plan on doing is trying to come up with a way where you can limit the number of clients per round of training. So this was something that as an individual contributor I faced, because sometimes we just are having very limited amount of memory size of GPUs, but we want a lot of clients to train. Say you want to train with 100 clients, but you really can't train all 100 clients at once because your GPU just doesn't have the capacity to do it. So I had to tweak the code to limit the number of clients and kind of go in a round robin fashion so that all of them get the chance to participate in the upcoming server rounds. That's not ideal, but I think it's really good, at least in a simulation sense, to get started with it. And another thing that I wanted to use was trying to drop clients based on performance. Although Flower doesn't have a way into it to directly unregister or drop clients, it was pretty interesting that they do have those procedural calls or the functionality to do it. It just hasn't been integrated as a whole strategy yet. So I made use of those existing, function calls out there to unregister or drop clients and also track the historical performance of these clients. And I think having this functionality would also be beneficial for certain contributors who are working in a very similar fashion as well. Some of the limitations that I see in this current work is definitely the sampling time. So if you noise an image, say for 4,000 steps, you would want to denoise those images for 4,000 steps just to get an image back. And that's not going to work out in an FL world. So there has been definitely a lot of interesting works from NVIDIA and other large tech companies to reduce the sampling time. And that's something that can definitely be looked at in the future work. And the next is the hardware limitation, considering it was just a graduate work and it didn't have a lot of computation, but it's definitely something to look as to how can you do things like model quantization, model pruning, so that you can really reduce the size of these model weights from just a 12-bit, which is something like an 8-bit value as well. And the future work that I see in this domain are that this work does not really actively look at the privacy concerns. So I think looking at things like differential privacy so that you can account for the traceability or accountability are truly, really exciting works you can look at, and also extending the work by including other data sets, looking at other modalities in it well, and also definitely thinking about it in a responsible AI sense of manner by looking at the fairness, bias, and interpretability of the model are really exciting works that can be done as part of the future work. And I think that's it for my talk. And any questions you have, please feel free to ask them away.
Super interesting area, and I also appreciate the way that you kind of laid it out there at the end in terms of interesting contributions that can be made through this work into Flower. I think you were saying it also implies some areas where Flower could be easier for doing this type of work if you're trying to change it basically, and then also more fundamentally about the topic you're looking at, where the future work really lies. So we have time for questions. I'm happy to take some. Let's do it in this new way. If you're in the attendees, you want to raise your hand, just do so. If anyone here in the panelists want to ask a question, also go for it. We have one from Javier. So Javier, ask your question.
Okay, yes. Well, I really enjoyed this talk. I have just a couple of very standard, not super technical questions, but I'm curious because I haven't had a chance to read the paper. How many clients did you have in your experiment, and did you find it like really important to have less clients so they can have more data, for example? Because I'm not super familiar with diffusion models, but I suspect that having more data would be beneficial.
Sure, that's a really good question. And the goal was to have a lot more clients. However, I had to start off with just 10 to 15 clients given the computation that I had, So it was something that was just started off with 10 clients. And given that the model size is also big, just to put things in perspective, if you want to train just one client, you would require almost 4 gigabytes of memory just during training. So that kind of indicates how large of a model it is. So if you want to even have 100 clients to train in parallel, you would have, this X amount of memory space.
Okay, and also I found interesting the part where you were saying that first you train your global model with a little bit of data on the server, and then you use a small portion of, I think it was this data, to send it to the clients. So all clients can have some kind of aligned data or aligned training procedure. I'm starting to see that being more and more common in other FL papers. So I was just curious to see if you have been thinking about, for example, not starting from a pre-trained model that you train on the server, but maybe starting from an ImageNet pre-trained model, and then say, okay, let me just personalize to Cypher or something like that. Did you consider doing something like this, or what you would expect to happen if you start from a super high capacity model, for example?
Definitely. I think transfer learning is something we thought about. I mean, although it wasn't implemented as part of this paper, it was something we did think, because training from scratch was not ideal. So like you suggested, starting off with a large pre-trained model and then just transferring the knowledge to a smaller model would have been definitely worked out. We did not actively experiment with that, but that's something that we can definitely look into.
Okay. And also, yes, one final question. Do you have to open source the code?
Yeah, so I have been talking to Nick about it, and I'm planning to open source it eventually, yeah. But it's something that I would be doing it. First, I'm going to start off with just open sourcing my code, and then kind of looking into ways I can open source some of these modules into Flower.
Okay, cool, great. Okay, thank you.
Sure, thanks.
Any other questions from the audience? I think I see one being typed in here. Let me just see. They're saying, you had I think a few slides ago. It says it seems to be implying a few slides ago there was this statistic about number of rounds. It takes like 11 hours per round, and so the question they're asking is how many rounds would it take for the model to converge? That's what they're asking.
So this actually, when I went try to experiment with this, I did not wait for it to converge, because that's going to take a really long amount of time, especially considering I'm training from scratch. So it was trained for around 10 to 20 server rounds, and each of them lasting for, say, 100 epochs. So this was the time that I could put into place, but I don't see it converging at this point. It had to be at least trained for several more server rounds to several more epochs, but something that I just stopped with was 10 to 20 server rounds.
I guess I'm not so familiar with the details of diffusion papers. What does a centralized diffusion model typically run? It's how many epochs does it normally use?
It's a lot. They usually train it for a large number of days, and given the computation they have, they kind of run things in just they divide the data sets and then they train it pretty fast as well. Yeah, I mean, although it does sound repetitive, I think the computation was the main reason that hindered me from running it all the way to see how it would look, so that I can compare it paper to paper with that of the seminal paper out there. But yeah, it was just trained for 10 to 20 just to see how things are running. Yep.
I know, it's super interesting. I mean, I guess they're just sort of trying to get that frame of reference for what the I guess you're taking an important first step, and it appears to be necessary adjacent steps before this could be done sort of like every day, for example. Great. Well, thank you so much for the talk. It's wonderful, wonderful stuff. And thank you for using Flower. We're always excited for like new use cases. Mm-hmm. Thanks. So I just have one more slide. Yeah, thank you. I have one more slide to share. Let me just, okay, I'll do this. I assume it'll just work. And that slide is to say thank you everyone for joining us today. It's been maybe it's been my most favorite Flower Monthly to date, because I really enjoyed the kind of contrast of the two content types that really dive into how federated learning is going to move forward. It's going to move forward by becoming more standardized, more interoperable, so it's going to be able to scale and so reach the kind of aspirations we all have for it. And it's also going to be driven forward by exciting new applications, new models, where we see that once we federate these models, these models just are just materially so much better. And so thank you, Fiona, thank you, Patrick, and thank you, Daniel, for really giving us some fantastic food for thought. I'll remind us all that come back next Wednesday is September 6th. We'll be at the same time, 1600 UTC. And as a reminder, if you want to give us feedback about Flower Monthly, there's a Slack channel here, #flower-monthly. There's the website for the Flower Monthly content. So in time, the videos will appear there as well as on YouTube. And then there's the Slack and the calendar, where we have these nice, friendly, typable URLs if you want to engage with any of those two types of material. So again, thank you everyone for attending today. It's been wonderful spending time with you. Take care.
Thank you so much.
Thanks,
Bye, everyone.
everyone.
Bye.
Bye.
Thanks, everyone.